Chapter 12, Matter. This lecture will help you understand atomic structure. The idea that matter is made up of discrete units is a very old idea, appearing in many ancient cultures such as Greece and India. The word atom comes from the Greek atomos, meaning indivisible. In 1977, French chemist Antoine Lavoisier defined the term element. He said that an element was any basic substance that could not be broken down into other substances by the methods of chemistry. Any substance that could be broken down was a compound. In 1803, John Dalton suggested that elements were tiny solid balls made of atoms, all of the same mass. He said that compounds are formed when atoms of more than one element combine. In 1827, British scientist Robert Brown looked at pollen grains in water under his microscope and noticed the grains appeared to be jiggling, a motion now called Brownian motion. Brown used Dalton's atomic theory to describe patterns in the way they moved. In 1905, Albert Einstein was able to describe that the seemingly random movements were caused by the reactions of atoms, and by doing this, he conclusively proved the existence of the atom. Matter is composed of atoms, and an atom is a fundamental unit of an element. Elements are materials made of only one kind of atom. Pure gold is an example, as it is made of only gold atoms. A molecule is the smallest part of a substance that still retains the characteristics of the substance. Water is a molecule made of hydrogen and oxygen. The term element is used when referring to macroscopic quantities. The term atom is used when discussing the submicroscopic. Atoms are ancient. The origin of most atoms goes back to the birth of the universe. Atoms are mostly empty space. The distance between the parts of atoms is quite large. Elements heavier than hydrogen and helium were produced in the interiors of stars. Atoms make up all matter around us. Not all atoms are the same size. The hydrogen atom is the smallest, with a diameter of 6 × 10⁻11 meters and a mass of 1.67 × 10⁻27 kilograms. Uranium is one of the heaviest atoms at 3.96 × 10⁻25 kilograms. To date, 118 distinct kinds of atoms are known. Only 90 are found in nature. The remainder synthesized in the lab. Moscovium, which is element 115, was created in 2013. Livermorium, element 116, was created in the year 2000. Tennessine, element 117, was created in 2010. And oganesson, element 118, was created in 2005. Hydrogen and helium form most of the elements in the universe, about 98% of all matter. The other 2% is everything else, such as iron, aluminum, oxygen, carbon, and so on. The Earth shows a different abundance than the general universe. Hydrogen and helium, being light gases, have escaped from the Earth. The most abundant elements in the Earth's crust are oxygen, silicon, and aluminum. A molecule is a group of 2 or more atoms held together by chemical bonds. The smallest molecule is the diatomic hydrogen, H2. The water molecule is composed of 2 hydrogen atoms and 1 oxygen atom. The glucose molecule is composed of 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Macromolecules can contain thousands of atoms. Atoms are not the fundamental units of matter. The elementary particles are electrons, protons, and neutrons. There are many more elementary particles, but these 3 dominate all the physical matter of the universe and will be the only ones we discuss. The first subatomic particle discovered was the electron. In 1906, J.J. Thomson was awarded the Nobel Prize for his 1897 discovery of the electron. Ernst Rutherford discovered the proton in 1917. The 1935 Nobel Prize in Physics was awarded to James Ch12 for the discovery of the neutron in 1932. The neutron has the largest mass of the three elementary particles, 1.675 times 10 to the minus 27 kilograms. The proton is only slightly smaller at 1.673 times 10 to the minus 27 kilograms. The electron's mass is 9.109 times 10 to the minus 31 kilograms. The proton and neutron have a diameter of about 8.2 times 10 to the minus 16 meters. The electron's diameter is too small to be measured and considered to be less than 10 to the minus 18 meters. Electrons have a property called charge. The observation of charge dates back to at least 600 BC, where charge could be accumulated by rubbing fur on various substances, such as amber. Electrons have negative electric charge. Protons carry a positive charge. And neutrons are neutral. Charge is seen to repel like charges and attract unlike charges. The magnitude of charge for the electron is 1.602 times 10 to the minus 19 coulombs, which is considered to be negative. The proton has the same magnitude of 1.602 times 10 to the minus 19 coulombs, but a positive charge. Matter is not observed to have a fractional charge of the electron. Quarks are elementary particles that, according to the quark model, are the constituent particles of protons and neutrons. Quarks are thought to have fractional charge, but so far have not been directly observed. Atomic structure describes the constitution of the nucleus and the arrangement of the electrons in an atom. The arrangement is different for the various chemical elements. J.J. Thomson in 1904 proposed that the atom is composed of electrons surrounded by a soup of positive charge to balance the electrons' negative charges, like negatively charged raisins surrounded by positively charged pudding. The electron, as we know them today, were thought to be positioned throughout the atom. Ernest Rutherford in 1911 performed a series of experiments using alpha particles, helium nuclei, to collide with gold atoms. If the plum pudding model were correct, the alpha particles would pass straight through. But he found that some of the alpha particles ricocheted directly back. He concluded that most of the mass of an atom is contained at the center, what we now call the nucleus. Rutherford did not comment on where the electrons are in an atom. Niels Bohr in 1913 depicted the atom as a small, positively charged nucleus surrounded by electrons that travel in circular orbits around the nucleus. In the quantum model, electrons do not orbit the nucleus like the planets orbit the sun. Instead, the electrons form a cloud like a standing wave on a string. This behavior is defined by an atomic orbital, a mathematical function that characterizes the probability that an electron appears to be at a particular location when its position is measured. Only a discrete or quantized set of these orbitals exist around the nucleus. The image shows the wave functions of the first 5 atomic orbitals in an atom. The regions depicted are the most probable locations of the electron, but its absolute position of the electron cannot be determined. The hydrogen atom consists of 1 proton orbited by 1 electron. The carbon atom has 6 protons and 6 neutrons in the nucleus orbited by 6 electrons. Uranium is the largest naturally occurring element. It has 92 protons and 146 neutrons in the nucleus, orbited by 92 electrons. The periodic table arranges all of the known elements into an informative array. Elements are arranged left to right and top to bottom in order of increasing atomic number, which is the number of protons in the nucleus. Order generally coincides with increasing atomic mass. The different rows of elements are called periods. The period number of an element signifies the highest energy level an electron in that element occupies in the unexcited state. The number of electrons in a period increases as one transverses down the periodic table. Therefore, as the energy level of an atom increases, the number of energy sublevels per energy level increases.